First, we'll start with the projectile motion topic. The pop quiz 4. In this question, in a game called Dart, a metal dart is thrown towards a dartboard, and the dart hits the dartboard as shown. The dart is thrown with a velocity of 15.6 meter per second at an angle of 5 to the horizontal. The dart traveled the horizontal distance d to the dartboard as shown, and it's not to scale. So you cannot use any measurement to get the answer, like the value of the distance. Just before the dart hits the dartboard, the vertical component of the velocity is zero. So means vertical velocity is zero means that is the maximum height. The air resistance on the dart is negligible. Show that the time taken for the dart to reach is about 0.14 second. So here the velocity, it is launched at a velocity of 15.6 meter per second. And it is making angle 5. So it will have two component. One of the component which is with an angle that will be equals to 15.6 cosine 5 degrees. And the other component which is opposite to the angle that will be equals to 15.6 sine 5. At the maximum height, the vertical component will be 0. So we will use the equation of motion according to that v is equals to u plus at. V is the final speed, the final velocity, that is 0, final vertical. U is the initial vertical, because whenever we use equation of motion, we always substitute the vertical components, because acceleration in horizontal component, there is no acceleration. So U, the initial horizontal vertical speed is 15.6 sine 5. Then acceleration is due to gravity, but it will decelerate. So we'll write at minus 9.8. So this will be minus 9.8 and the time is t. When we simplify, so 9.8 into t is equals to 15.6 sine 5. If we need t, that will be equals to 15.6 sine 5 divided by 9.8. So when we divide, this will give us the time the dart will take to reach the dartboard. That is about 0.139 seconds. So the value of a t, 0.139 second, which is about 0.14. Then calculate the horizontal distance. So we have the time. Because whenever vertical motion we use, as we are taking a vertical component dimension, the vertical component is 0 here. So if the vertical component is 0, so this velocity will have two components, horizontal and vertical. So whenever we use equation of the motion, we always use the vertical component. So vertical component is 15 sine 5 and the horizontal component is 15.6 cosine 5. So vertical component is responsible for the vertical motion, and we have the final vertical 0. Using that, we worked out, like we have final velocity, we have initial velocity, and we have acceleration, which is due to gravity. We work out the time. To get the range or the distance, we use a horizontal distance. So we have the time is 0.139 second. So we need the horizontal distance. So always use, like, speed is distance over time. So if we need the distance, speed multiplied by time. So we'll substitute the horizontal speed here, which is 15.6 cosine 5 multiplied by time 0.139. So 0.139 second, it is the total time it takes to hit the dartboard. So when we multiply, this will give us the range. Which is 2.16 and the unit will be meter. So whenever horizontal component, use the horizontal component of velocity. When vertical displacement, use the equation of motion. And whenever we use equation of the motion, we always substitute the vertical component, because horizontal component, there is no acceleration or deceleration. In question 2, a tennis player can practice using a tennis ball machine. The machine project the ball at a horizontal, so height from a two, and it is launched horizontally. So what about the vertical component? Vertical component of a velocity is 0, because it is launched horizontally only. So the initial velocity is 0. And what is the vertical displacement? The vertical displacement is 2.54. And it will have an acceleration, the vertical acceleration, which is due to gravity, 9.8. Horizontal, initial horizontal speed will be there, but initial vertical speed is 0. So again, we'll use the equation of motion. We have u, which is 0. We have a, which is 9.8 as it is moving down, 9.8 meter per second square. And we have the displacement, which is 2.54 meters. So if we need the time, the equation which involve the time, s is equals to ut. The equation of motion which include the time, s is equals to ut plus half at square. S is a displacement which is 2.54 vertical displacement. Initial vertical is 0. The time we don't know, plus half acceleration. This time it will take as positive as it is moving down. It will accelerate and t. So this will be 2.54. This factor will be 0. 9.8 divided by 2, 4.9 t. Or 2.54 is equals to 4.9 t if we need t. 2.54 divided by 4.9. So 2.54 divided by 4.9, that will give us 0.72. So it will take 0.72 seconds to reach the bottom. The ball lands on the ground at a horizontal distance of 17.89. Calculate the velocity the ball is projected. So when this ball is projected, the horizontal distance with the ball cover is 17.89 meters. And we know how much time it is taking. It is taking 0.72 seconds to reach the ground. We need the speed, the horizontal speed, because horizontal speed, there is no acceleration. So we'll use a formula, speed is distance divided by time. So the distance it covered is 17.89 and the time it took 0.72. So this will give us the launching speed or the horizontal speed at which it is being launched. So 17.89 divided by 0.72, which is 24.84. So 24.84 meter per second. That is the speed at which it is launched. Vertical component is 0. There is no vertical velocity. So the vertical velocity or vertical component is 0 in the beginning. The initial velocity of a ball as it projected from the machine can be increased. How increasing the initial velocity would affect the angle at which the ball hits the ground? Look, when this ball is launched, when any projectile is launched from a certain height, so in any projectile example launched from a certain height, so it will hit the ground. So this is the final velocity at which it hits the ground. This final velocity will also have the two components. What are the two components of this final velocity? One will be the vertical component of the velocity. Another one will be the horizontal component. This horizontal component of the velocity is same throughout. Like but what about the vertical component? The vertical component depends on the height from which we drop. It does not depend on the horizontal speed, it depends because the two components are independent of each other. And if we need this angle at which it hits the ground, because we have the perpendicular and the base, so that will be equals to tangent theta, because tangent theta is perpendicular divided by base. Like the vertical component of velocity divided by horizontal component. Or theta equals tan inverse, the vertical component divided by horizontal component. Now what will happen if we increase, if we change, like example, so the total angle depends on the vertical and the horizontal. But vertical, in this example, the vertical component won't change. Why the vertical component does not change? Because we are dropping from the same height, so the vertical component remains same. So only thing what happened is a horizontal component change. Because horizontal component depends on the horizontal speed which we are dropping. So if we increase the horizontal speed, as a result, what will happen? It will hit the ground with a greater horizontal speed. Vertical speed won't change. So as a result, if this value of the vertical component is increasing, you can work out, like say, just take any number, like say take tan inverse 3 over 4, and then take tan inverse 3 over 5. Which value, what happened to the value? Like this 3 is any number, you can take constant vertical and you increase the horizontal x. So when you increase this x, what happened to the angle? What is the value for tan inverse 3 by 4? The value for tan inverse 3 by 4. What is the value for tan inverse 3 by 4? 36. And what is the value of tan inverse 3 by 5? 63. So what you can see, as the angle, as we increase this, as we increase the horizontal component, tan inverse 3 by 4 is what? 30.9. Okay. What is the value for 3 by 4? Tan inverse 3 by 4. 36. Okay. And this is 30.9. Okay. Okay. So as you can see, as we are increasing the horizontal component, as we increase the horizontal component, what happened to the value of angle? The angle will decrease. So here you will, like if we have a greater horizontal component and we have a smaller vertical component, so if we are taking the angle with of a resultant with a horizontal, this value of an angle will decrease. Because if I draw a smaller horizontal and I draw greater vertical, so you can clearly see the value of the angle with the horizontal will increase. So the points you will mention, like the vertical component does not change because it depends on the height from which we drop. And the horizontal is increases with the initial speed. So as a result, what will happen? The angle of the final velocity increases. Sorry, angle of the final velocity decreases. Is it clear? This one? Yes, any doubt, Abdullah? So this was the pop quiz, which was related to the projectile motions.